Okay, well, let's move to step 3. You should be looking at your data now. We're going to look at the strengths of our students. How well did they do in any particular standard? Which did they do best in this geometry unit?
It would appear to be that Math Practice 5 consistently across the board. It seems like we had some pretty good scores.
And Math Practice 5 is the practice about using tools, appropriate tools. Okay.
I would say they did really well on Standard 3, 7G, Standard 3.
Standard 3, describe the two-dimensional figures that result from slicing three-dimensional figures. Okay. They had a overall 49%. So what do we think contributed to them doing so well in that particular standard?
With that particular standard, I know the lesson that we wrote was really hands-on with the Play-Doh model and having them create it and actually slicing it with a dental floss. So having them actually have that model in hand and seeing it firsthand, I think they really connected with that and really grasped what we were trying to get across.
Well,
Go ahead, sorry.
for our class, we're not able to do the Play-Doh, but this is the last topic that we discussed, and I think it has the biggest impact on them, especially we played a video that they really like. It's about a ninja slicing the fruits and all that, and so even if it's not hands-on, the visual representation helped them a lot.
And the fact that it was the freshest in their mind still, so yeah, that definitely helped.
I also implemented a 3D computer model along with the slicing with the Play-Doh, and also used a game that Khan Academy brought out with 3D slices. So I thought that that also engaged them a little bit more.
Okay. What kind of strategies can we continue to use to enrich this for our students? What kind of things can we do now to continue this great trend?
I've been thinking about that a lot because it seems like the geometry unit is always the unit that kids really engage in, and it's because of the hands-on activity. And so part of my frustration has also been, for instance, on other units that aren't so hands-on, what could we create? I saw so much engagement that I know that it's going to impact my teaching on the next unit and on into next year, but I'm still, hopefully my colleagues here can give some other great ideas, but I think definitely bringing that hands-on model to the table really helps them tremendously.
So what kinds of things can we think of?
Well, no, this was around the time that we also started doing stations, started introducing stations. And so that was also an opportunity where we could split our class into smaller groups. And so it allowed for us to meet with, instead of 30 kids, maybe 7 at a time. And so I think that helped a lot.
We also did start chunking our lessons. So because we had to do the station rotations, you only had maybe 15 to 20 minutes to meet with your group before they rotate. So that meant that instead of having an entire mod lesson, you actually had to condense it and make it maybe 10 to 15 minutes to hit the key points, and then they rotated to a different station.
Ms. Fragante, would you also say the tablets, how we had them search for the words instead of just giving it to them on the screen like they actually had to, and it had games and stuff that you could play with this. It made it a little more than them just copying down Cornell notes from the screen itself. So that helped.
Yeah, exactly. I think also that maximizing the technology that we have really helped them. Like it's that time of the year when we have the clickers, the iPad, all the technologies available to us. That really helped them.
And so as we move forward, as we're doing more stations throughout till the end of the year, we're saying we want to continue with adding these pieces of information about geometry into the stations. That would be one of our instructional strategies, so that as we continue, they're actually still using this actual standard and keeping it as a great standard for this unit.
And also, when we get to the technology piece, actually pull in whatever we're doing in the classroom specific for Think Through Math, how you can align whatever you're doing in the classroom on Think Through Math. So picking those standards that we're actually doing in classrooms, so it reinforces it when they're in the small station at Think Through Math on the computers.
Okay.
And just to piggyback on the fact that of the stations, we find that the students perform better when they have a short period of time to focus and to be able to get up and move. Middle school is real important that you have to move them after a period of time. So 15 minutes max, and that seemed to work for them very well.
And I know this may not be the particular place in the CFIP process, but thinking ahead in that probability unit, there will be a lot of opportunities for the hands-on piece for them.
Okay. All right, so when are we saying we're going to have this completed? When are we going to, we're doing this immediately? We want a date? How we want to, so that we can be accountable to this?
I think being that it's the beginning of May, what we can do is try to implement that for the remaining weeks in May, since in June we're going to actually start our finals. So maybe for the next 3 weeks, try to start implementing these strategies.
And I don't want us to forget about the foldables, because that was very important. That was also something that they were able to carry around with them. Once they created it, then they had that, and it was a concrete apparatus that they could work with constantly at home and here in school. So that was
ensuring that in the next few stations and opportunities that we have, that they're actually using those foldables, not just having them and leaving them in a notebook. Right. So being intentional about using those in our stations. Okay, so let's look at the places where our students had challenges. Which particular standards and mathematical practices did they have a challenge?
We were 7G4, the knowing the formulas for the area and circumference of the circle. That was a low score for us.
It looks like that was a low score for everyone.
Yes.
7G4. Which is, oh yes, you did say that, knowing the
knowing the
formulas,
formulas,
absolutely.
yeah.
Anywhere else where our students had a challenge?
It seems to be the greatest need.
Oh, the 7G2, which was kind of using the tools like the protractor and such appropriately. It was for us. I think we scored a little bit low.
Or
am I reading that
7G?
right? 7G2 or no?
7G2. Well,
Draw construction.
7EE4 was 32%, which was the next lowest.
Yes.
Which is solving real life and mathematical problems using expressions and equations.
So it goes back to problem solving again.
Okay, so 7EE4 and 7G4.
Those are the only two we're using. We're going to focus on.
We all agree on those two?
Yes.
Okay.
Okay. And so what do we think the learner-centered problem here is? So let's take one at a time. Let's look at 7G4, which is, well, they're really about the same thing. One is solving real-world problems with the geometric formulas, and the other one is solving real-world problems. So they're actually very, very interconnected. So it kind of makes sense that those are both our lowest areas. So why do we think that there was, as we move into step 4, what would be the learner-centered problem? Why do we think that they had a challenge with those two?
Well, when I was looking at those particular problems, I noticed that they had given the formulas, and when I was looking at their student work, I'm recalling that they were able to figure out the area of a circle. They were able to figure out the area of the square, but again, it goes back to the problem solving, because that wasn't the only problem. They had to find out the used copper wire in the circle, how much, and then they compared the silver wire with the copper wire. So again, I think it's those reading strategies and teasing out the actual information.
Okay. Any other things?
They seem to be so used to basic computation that they're not reading and pulling out that data, that extra data that's needed. They'll stop after step 1, and there may be a step 2 that's necessary.
Now, I'll piggyback off of that. Actually, looking at standard 7G4, that looks like it's the only standard, and correct me if I'm wrong, that they actually use a formula. So not only do they know how to solve the formula, they actually have to know how to apply it to the problem.
Yes.
And that kind of speaks to what you were talking about.
All right. Any other issues that we see a part of the learner-centered problem?
I would say with 7EE4 that they have to construct the equations and inequalities, but they also have to reason. So they have to explain how they reached that answer. So a lot of them were able to say, yes, this was the correct answer, but they had no way of proof. There was no proof. There was no mathematical proof of saying that's how I reached my answer.
Okay.
And this was also a non-calculator test, and on another one of the questions where they were working with a formula with the volume plugging into the standard 4, the numbers were very large. And the thought in my mind is I'm wondering in the actual computation with paper and pencil if that didn't give some of the errors, because I noticed they had some points, but they didn't have all of the points because they didn't have the final answer.
Okay.